It was a 300-ton chiller, and they began to get the pumps cavitating, and before they could get it stopped, basically tore it up to the point that it took them 92 days to fully recover.
Hey everyone, welcome to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Fred Gordy. He's the Director of Cybersecurity at Intelligent Buildings, and our topic today is building automation security. I mean, we walk around, we use big buildings all the time. We go into skyscrapers, we go into large malls, and we kind of take it for granted. We don't really see the, sometimes thousands of CPUs that are in a sense, animating the building. So it's this sort of hidden world that Fred's going to take us into.
Okay, then without further ado, here's you and Fred.
Hello, Fred. Welcome to the podcast. Before we start, can you say a few words about yourself and about Intelligent Buildings?
Absolutely. Andrew, thank you for having me today. It's an honor to join you and the guests that I've heard on your show. Really good podcast. Thank you. Real quick, a little bit about myself. I was an IT guy up until about 2000. And then this company saw my resume and wanted me to come interview with them. And they started telling me about what it was they were doing. And this thing called automation control or building control is what they described. And I did something you probably shouldn't do in an interview. Is I said, "Are you sure you're interviewing or you got the right guy? I'm an IT guy." And they said, "Well, absolutely, because building control systems are moving towards network-based connectivity." And so that's how I got into this industry. I've been in it about 20 years. I spent specifically about 16 years working as a programmer and a designer of control systems. I've worked with Fortune 50 companies, and in about 2014, had a realization that, there's a huge problem here, and we're the ones that created it. That's when I began my quest to bring cybersecurity to building control system space. Now, this is not the same as industrial control. Building controls, and I'll explain a little bit later exactly what that means. And what I found at the beginning was IT was not a fit per se. I mean, there were some aspects of it that did. ICS is what I like to call our cousin and not our twin. So there are definitely differences between ICS and building control systems. And so at the same time that I started my quest about 5-6 years ago, Intelligent Buildings also started working on a building cybersecurity program. And then I came on board with them, and together we've been building a cybersecurity program specifically for building control systems. And a little bit about Intelligent Buildings. Intelligent Buildings is a smart building consultancy. What that means, and let me say this, they've been around about 16 years. So it's not that they've only been around about 4 or 5. They've been around 16 years, and it's this smart building consultancy that they've been doing. It was a natural progression to go add the cybersecurity layer to it, because the whole intent of Intelligent Buildings is to work with Fortune 50 companies to help them understand all of this smart building technology, how best to use it in their building for energy efficiency, for customer experience, and to also detect faults and potential future problems. So that's a little bit about me and about Intelligent Buildings.
So thanks for that. Our topic today is building automation. Can you give me an idea of what the physical systems in these buildings look like, say, in a skyscraper? What's there? What's it do? And what are we worried about?
Okay. So when you think air conditioning, most people think about what's in their house. There's maybe a window unit, or there's a unit outside you've got that, has the spinny fan that's out there running, and then there's an interior piece. Well, in a skyscraper, the heating and cooling systems inside of there are principally, they're the same. However, the way they do it is they pump cool water through the entire building to cool it, or they pump hot water through to heat it. And what happens is there's a thing called a chiller. It's a large piece of equipment that houses 54-degree water typically, and the water comes through that's been already out in the building. It comes through, and the chiller takes that water temperature down, and then it goes back out, and it goes to these things called air handlers. And the air handlers are there could be, let's just say, a 30-story building. Depending on the square footage of each floor, there could be anywhere from 1 to 8 of these air handlers per floor up this 30 or 40-story building, or every other floor. So as you can see, there can be 20, 30, 40 of these things. But anyway, the water comes up to them, and there is big fans in there that blow across those pipes, and that pushes the cool air out. Now, down in the central plant where the chiller is, there's also things, and I know this is kind of crosses over into the ICS world. There are these things called VFDs, variable frequency drives, because there's all these pumps that are necessary to get this water circulating. Also in the central plant is a boiler, and that boiler is can be piped into the same pipes, or which most time it's not. It has its own set of pipes. But anyway, so the pipes themselves go through the building just like the cooling side, and the air handlers blow across those and blow the heat out. Same kind of principle. But anyway, so with that in mind, the other things inside of the building, the lighting control aspect of it, there's contactors and things throughout the building, and there's a central brain, if you will, that runs the lighting control. The access control has a central database, and then the access control being the card access. Those have devices throughout the building wherever you see a card access, and they have a mirror image of that database inside of them. So to give you an example of what can be done from an attack standpoint, we had one particular customer. They got attacked remotely. Well, the first thing they got ransomware on their front end, because these guys don't use these front ends like they should be, or the application hosts like they should be used. They're actually sitting on the engineer's desk, and these guys are using them like their workstation. And in some cases, or a lot of cases, they're using them as their personal PC. So they'll open an email, and we see this time and time again. This is the typical attack vector, is the ransomware gets released on the front end, locks them out of the system. They can't do anything with it. Well, in this particular case, not only did it have that, but it also launched a command control. And so the guys remotely were able to get in. They locked the head end out, or the application host, and then they went into the central plant, and they started doing things with the VFDs to run them up and stop them, and run them up and stop them. And then they began to get the pumps cavitating, and the before they could get it stopped, it was a 300-ton chiller. Basically, when I say tore itself apart, it didn't come totally apart, but what it did do is it made it in such a tore it up to the point that it took them 92 days to fully recover from this particular incident. And this translates into thousands of man hours, as you can imagine. And that's one of the, I guess, extreme examples in this particular case.
Fred just threw around a few technical terms there, Andrew. Could we slow things down a bit?
Sure. I think the key concept that Fred mentioned was variable frequency drive, VFD. This is a kind of power supply. It changes the frequency of alternating current that drives a pump. The upshot is that if you can change the speed of the pump by changing the frequency of the power that comes out of the VFD. Now, you might have heard of these things before. Variable frequency drives were made famous in cybersecurity, in the cybersecurity world, by Stuxnet. This was the attack on the Iranian nuclear enrichment program. The VFDs there sped up the uranium centrifuges, slowed down the centrifuges, and eventually destroyed maybe 1,500 of them. In Fred's incident, the drives were powering water pumps that were pushing, cooling water or heating water for that matter, I don't know, water of some sort through a building. The attacker sped up the pumps so fast that they cavitated. Now, cavitation is where the blades of the pumps move faster than the water can move, which briefly produces little pockets of gas behind the blades. When the water catches up to the blades, these pockets of gas collapse, which releases a lot of energy. I mean, I've heard people say that when a pump is cavitating, you can hear it. It's loud. It's like rocks are being pushed through the device. And if you leave a pump cavitating for a little while, the blades are damaged. If you Google pump cavitation, I did this, you can see pictures. It's like worms have been eating their way into the steel. It's really quite amazing. So his example is one where the attackers sped up the variable frequency drives and thereby sped up the pumps so fast that the pumps started cavitating and suffered physical damage that took over 90 days to repair.
Just a clarification, though, you talked about a central plant. When I think air conditioners and skyscrapers, I think, on the roof often you'll see these structures, or somewhere you'll see a structure that's pumping heat back into the atmosphere. The heat has to go somewhere when you're cooling air on a hot day. How's that artifact connected into this infrastructure?
The cooling tower, that is what it's called. So what we call the return from the building has picked up all this heat, right? So it goes through the cooling tower. The water rains down across this grid, if you will, or looks like a washboard in some cases, and all the heat is released. But when you mention the other units that are up on the top, there is another cooling system. It's called a rooftop unit, and those are ones that are not dependent on a cooling tower. On a central plant. They just pretty much are standalone. Those are more like the air conditioners that are in your house. And there's even another one that's a kind of a mini version of the air handler in central plant, and it's called a SWOD. And basically what it is, it's individual units that have their own little pumps and pipes, and it's more of a compact system.
Andrew, having grown up in New York City, I'm personally pretty familiar with seeing, giant cooling machines on rooftops. But when Fred mentioned the units that would be parked, in the parking lot, I'm not sure what he means there. Is he saying that you could have a cooling system just sitting out in the parking lot of a building?
Short answer is yes. In my understanding, there's a fair variety among sort of big iron air conditioners. There's the sort of units that look like railroad cars sitting on top of buildings. You see them on top of sort of smaller buildings, in my experience, lower buildings, malls and stuff like this. But the big cooling towers, you might see them on top of big buildings. You don't often get to see the top of the really tallest buildings. But let me tell you a story. I do remember I was, getting some routine tests done at a lab. The lab was on the 9th or 10th floor of a hospital. The hospital is 15 floors big, and it's a massive building. It's a massive complex. And I'm looking out the waiting room window, down 9, 10 stories, and I can see a structure that's maybe 3 or 4 stories tall beside the hospital. Not as big as a hospital, but it's a fairly big building. And, from the top, you could see this massive fan slowly moving. It took maybe 5 seconds to make it all the way around once, but it's a massive fan moving a lot of air. And from Fred's description here, that would be a cooling system. The water from the air condition is being pumped into that building, and is somehow being exposed to the air moving by the fan, and cooling off the water so it can be pumped back into the rest of the building. So there's some variety here, is I think the point he's making.
Can you talk to me now about automation and connectivity? How are these things automated, and what kind of networks are we talking about? How are all the different pieces? Where are all the different pieces of automation, and how are they connected?
Okay, so let's start with the basics. I told you I would come back to this. So going back to that example with the cooling towers, the central plant that has the chiller and the VFDs and the pumps. The air handlers that are throughout the building, what they do is the people that adjust the thermostat, if you will, that makes the air handler move more air or less air, which then also requires more water to come through to it, because if there's little or no demand, then the chiller is sitting there more idle. But as more people come into the building, then the heat load begins to creep up. I'll get into the automation side of this, or the how the system does this on its own. But the bottom line is, it sees the heat load, and then it begins to bring the temperature down. Well, the pump speed up, which pushes more water through the building. The fans speed up on the air handlers and blow more air throughout the building to cool the building down. Now, to your point about how are these things connected, so in our industry, BACNET is pretty much king. And if you're not familiar with BACNET, it's a communication protocol that is very open, and I know they're working on secure forms of it. But right now, no username and password is required. It is very open. Anyway, so there are networks there, and these devices are running on the network with an IP address, and they're communicating. So in the example that I just used, what happens is there is these things called supervisory controllers. Supervisory controllers have basically could run their segment of the network by themselves. So any of the field controllers, they're the kind of the more of the dumb controllers that are out there that might be connected to the air handler. The supervisory controller may be controlling 20 air handlers. They're all sending signals back to it via BACNET, and then the supervisory controller then sends a signal to the VFDs and the pumps and the chiller. Hey, I need more water. I need more. I need the temperature to be lower. So, BACNET is one form of protocol that we use. There is some Modbus, but most of that is specifically around power monitoring, that kind of thing. And there used to be a standard called LAN, and when I first got in the industry, that's what everybody was driving toward. But that's pretty much been, I don't want to say put on the shelf, but it's not as prevalent as it used to be. And there's a little bit of SNMP, but for the most part, the protocol is BACNET.
Let's talk cybersecurity. You've talked about a protocol that has no authentication. Does that protocol go across the internet, or is that strictly inside the building? I mean, is the threat here people, walking up to a wiring jack in the building and messing with their own building stuff, or is the threat here with attacks coming across the internet?
The answer is yes to both, and that's the scary part. If you were to use Shodan, and if you're not familiar with it, it's basically the Google. Some people call it the Google of connected devices. There's also another one called Senses. But if you went on either one of those and typed in BACNET, or better yet, if you type in BBMD, which stands for BACNET Broadcast Management Device, it's basically a BACNET router. Okay, so if you type that into either one of those, you're going to see not a bazillion, but you see tens of thousands of these things out there. So they're exposed directly to the web. You can, same thing inside of a building, you can, scan the network and find the BBMD. And the thing about finding the BBMD, if you find one BBMD, there could be hundreds of devices connected to that. So no username and password, whether you be outside the network or or outside on the web or inside in the building. Once you get to that BBMD, you now own the network, because like I said a minute ago, BACNET is king in our industry. So think about the implications. Now, let me give you a story. We had a particular customer that their IT department, once we gave the assessment reports, they were not very happy, because they told us, we spent all this time and money and effort, and we've redone our networks. There is no problem. And we told them, so we're here to assess the building control systems, not necessarily your network, but we do, as a result, kind of touch on that, and we're not going to change the score. And anyway, a lot of brouhaha went back and forth. One of the guys on my team, like a few days later, was just we call it hunting. He was hunting and he was using Shodan, and he found one BBMD for this customer. And this customer has buildings across the United States. When he hit that one BBMD, he was able to get to over 1,200 devices across their portfolio. And that he didn't go any further. He said, hey, these just came up. But what we know is, had he begun to dig, the fact is he probably could have found thousands of more.
So some of that sounded a bit like alphabet soup. Let me try and make sense of some of the acronyms. BACNET is a Building and Automation Control Network. It's the name of a protocol that's used commonly for devices that are used in building control. The problem with BACNET, and Modbus is like that. It's a very old protocol, a very simple protocol used for interacting with programmable logic controllers and other devices. The thing about both of them is that there's no passwords, there's no authentication. If you send a Modbus device, if you send a BACNET device a packet saying, change register 23 to the value of, 800 degrees, it will just do it. It will not ask the question, who are you? It will not ask the question, do you have permission to do this? If you send it a command, it'll do it. So, this is the problem. You connect to a BACNET router, this BBMD device. You connect to a router that's connected to 1,200 BACNET devices. That router will route your commands to any one of those devices, and they will do exactly what you tell them.
Now, he also mentioned Shodan, something that I've heard of in passing but have no experience with.
Shodan is like a search engine for devices. I mean, Google is a search engine for web pages. Shodan looks at Google, connects to port 80 or port 443 TCP ports and pulls web pages and indexes them. Shodan asks, what other ports have you got open? And, if you point it at a web server, it'll say, that looks like a Linux web server. If you point it at a Modbus device, it'll say, that looks like a Schneider Electric PLC. If you point it at one of these BBMDs, it says that looks like a BACNET router device. And so you can go to Shodan and ask, what's on the internet? And can you, give me a list of all of the BACNET router devices? And now you can connect to these things. This is very bad. One of these router devices, without any kind of protection that you can just connect to and give whatever command you want, that should never be on the internet.
And is Shodan more useful to the attackers or the defenders in this case?
It is unfortunately used by both. In principle, Shodan is to be used by defenders so that you can search and you can localize Shodan searches by geography, is my understanding, so that you can search. Let's say I have a building in this area and in that area. Tell me all of the devices that have IP addresses in that area and what kind of devices there are. There's a BACNET router there. That should not happen. And you go in yourself and fix these problems once you find them. That's the principle. But to my knowledge, it's it's used by the bad guys as well. No fault of Shodan's. If Shodan didn't exist, the bad guys could build their own, is the point. So, the capability of scanning the internet and identifying devices is well understood. And Shodan gives the good guys a chance to get in there without, getting involved with the dark web and trying to pay one of our enemies to give us the information about how to protect ourselves. Shodan gives us the ability, the same tool that they have, to be able to, find our own vulnerabilities and fix them.
I see. So even if you made Shodan exclusive to the folks who you want to be using it, that would be in effect useless because you could just replicate it.
Short answer is yes, and I think the long answer is they do try to do that. They don't try to take money from people who are actually hacking, but it's not all on Shodan's shoulders, because the ability to scan the internet is something that lots of people have, that you have in your basement. If you were to set up a Linux box, you could start searching for BACNET devices by yourself without using Shodan or anybody else, just trying to connect to things.
So let me come back to something you said a little bit earlier. Security is both technology and people. And you gave an example of one of the people, sitting on an application server, a workstation, and using it as a personal PC and messing up the whole building. Who are these people? How many people do you have in a building that operate these systems, that are responsible for these systems? And what do they do all day? Sort of what's a day in the life of these folks look like?
Typically in most commercial real estate, or CRE as they call it, buildings, there could be a staff to anywhere from 5 to 10 guys that are responsible for running that building. So if you think of a company, let's just say that has 100 buildings, well, on the low side, they're going to have 500 guys that are responsible for operating the building. Now, we need to look at, as you said, technology is one aspect, but the people are the big part of this problem. Is these guys have historically come up through the ranks from fully mechanical systems, meaning they may have pneumatics that drove certain things, to now computer control. And they also, too, is the only thing that really mattered was the people in the building being either hot or cold, the comfort, let's just say. So when these guys come in the beginning of the day, the first thing they're going to do is, check the system out, and they're going to look to see if they've had any hot and cold calls. And if they have, then they're going to adjust the system accordingly. But they also are responsible for doing chiller checks and that kind of thing. Well, they've been working completely isolated, completely with no oversight, because the only thing that really mattered was, hey, make my building run right. That was the message from the top down. And that was the message from the tenants inside the building. I just want to come in and my lights work. I want to make sure that my office is comfortable. And that's pretty much it. So nobody was really paying attention. There wasn't processes and policies that have been put in place like it is in IT, which, if we can stop to kind of give you perspective, if you plant IT here, then ICS is behind them 4 or 5 years. Well, building control systems behind ICS 4 to 6 years. So notice the large gap. Now, so when we're talking about cybersecurity, we can go in and we can remove things from the public, remove things and stop them from being public facing. We can put all these policies and procedures and everything in place. You have a culture that is 30 to 40 years old that has been running independent, and they don't really, IT hasn't paid attention to them because IT has enough to take care of. They don't want IT to look at them because then they're going to tell them what to do, and they don't want anybody. And I'm not trying to make it sound like these are bad guys. These guys have a huge responsibility. They know a lot of stuff. They're responsible for millions of dollars worth of equipment. You just have a culture that has to change. So, to sum it up, I guess, is the guys, a day in the life of these guys is, I want to make sure that I am taking care of the building and making sure that the people that are paying good money to be in this building are comfortable and have every service that they paid to have. And beyond that, they don't have anything. The other thing, or they don't think of anything beyond that. The other thing is, as I mentioned earlier about the front end application server. In the IT world, if you have a SharePoint server, nobody would ever think about looking at Facebook on SharePoint server, right? Well, here is a thing that is running a multi-million-dollar building, and the guys come in and it's sitting on the desk. I can remember back when I used to do this, they used to complain about, we would tell them, hey, you need to get a workstation. Well, I got one right here, and it would be the application host. They didn't want to spend the $1,000 to get the workstation. Well, anyway, they come in, they sit down at that machine, they make those adjustments that I told you about, and then they go check Facebook, and then they check their Gmail account, and so on and so forth. It's been the stats that we are collecting is 80% of the attacks have come from ransomware, and 100% of them were avoidable had that guy not been on that front end using it as a PC.
At Waterfall Security Solutions, we are the OT security company. To help customers and other industrial owners and operators in this difficult time, Waterfall is extending our free remote screen view license program through the end of 2020. Unidirectional remote screen view is the most secure remote access possible for industrial sites. The design of Waterfall's unidirectional security gateways enables remote support while physically preventing any remote attack from reaching back into the protected network through the gateway's protective hardware. For details of the program, please visit the Waterfall Security Solutions website or reach out to your host at andrew.ginter@waterfall-security.com.
Andrew, I'm not familiar with many attacks on buildings of the kind that we're talking about here. Is this more common than I'm aware of?
I don't know about commonplace, but there have been incidents. I mean, Fred mentioned one where, pumps were cavitated and damaged. There was an incident a handful of years ago. The Sands Casino in Las Vegas was hit by Iranian hackers, and a lot of it was shut down. You hear about security conferences at hotels on a regular basis. Somebody's got a presentation on building automation security, a pen tester, and gets up on the third day of the conference and says, the problem with the lights last night where they were all flashing, that was me. The hotel's wide open. So, there have been incidents.
I take your point, Andrew, but what Fred was getting at there is that building automation might require a cultural shift. Now, even if a few incidents have occurred, the last time I counted, there are quite a few buildings out there, and most of them haven't been hacked. So wouldn't we require a little bit more impetus before we can expect a real cultural change in this area?
I'm not sure we do. I think that a cultural shift is needed, and the reason is straightforward. What's it cost to build one of these, a 50-story skyscraper? As far as I know, it's like $1 billion. How much rent, how much income do you get return on that investment? You get millions of dollars a month from tenants through 50 floors. If those tenants become unhappy, that income stream is in jeopardy. If we talk the security posture that Fred described here, sounded to me like we had an episode a dozen episodes ago, starting from zero. This sounds like zero. So, is it reasonable to jeopardize that revenue stream because you haven't done anything on the cybersecurity side? You've connected your BACNET routers directly to the internet. You're reaching out to Facebook from the application server. This makes no sense. The very basics, at least, have to be put in place, and it's going to take a change in perception for that to happen.
So that brings us to the question of the question we always ask: how do we fix this? What should people be doing to address these problems in big buildings?
The thing about it is, when you first take a look at this, and if you know what I know, looking at the building, and you're the guy that's going to have to get this all shaped back up, it can scare you to death because there is a lot of things that are wrong. However, there are so many low-hanging fruit, almost no-cost things that you can do that are bad practices. Just go into a basic best practice. For example, like you mentioned before, are these things exposed? Yes, there are a lot of them exposed. Statistically, about 50% of the time when we do an assessment, we find at least one or two things that is exposed, which if I get to the one or two things, then I can go on through the rest of the network. But anyway, if you get those things off from being public facing, the other problem is a lot of time it's shared accounts because that's easier. Everybody doesn't have to remember their own individual username and password. So there's shared accounts with the staff, but there's also shared accounts with the vendor. So just by taking and giving each user and enforcing that each user use a unique username and password, you can begin to take your risk down tremendously. The other thing too is know what you don't know. Almost 100% of the time when we do an assessment, we find things that nobody knew was there. And the only reason we're finding them are that is the case is because nobody's doing any kind of asset management. If you went in and cleaned your network up, meaning you did ran a scan. Okay, for example, this is a lighting control system. Well, if I find a Raspberry Pi on there, if I find a printer on there that doesn't have anything to do with it or whatever, just remove anything that shouldn't be there. And then the other thing is, we run into this particular hospital group. We found a lot of abandoned in place devices that are still live and cooking and have hadn't been patched, hadn't been touched in years. And then finally, take a look at your systems. Are they still supported? There are tons of unsupported systems out there who have not been patched or touched in 10 years. Because in our industry, it's not like IT refresh of every 3 to 5 years. It's like we refresh when it dies.
I wanted to jump in real quick. I heard the term abandoned in place, and I actually went and looked it up. Apparently, it's a term that's commonly used in the renovation industry. When you put out a contract or you request a proposal to renovate a building, with 20-year-old infrastructure, and you want to upgrade it, often the new stuff, whatever it is, air conditioners or anything, the new stuff is physically smaller than the old stuff, and so you'll often have a choice. The proposal will say, give us 2 cost proposals. One is rip and replace, get rid of the old stuff and replace it with new stuff. And the other one is abandon in place and replace. So put the new stuff beside the old stuff. Leave the old stuff there. There's not a lot of liability with a lot of the old stuff. Unless there's computers in the old stuff. And if the old stuff has computers and they're wired into the electrical system and they're left on, now you have the new computers that you're paying attention to, and you've got all these old things left on your network that no one's paying any attention to, and they turn into a cybersecurity liability that people really haven't anticipated in the abandoned in place scenario.
Is that realistic? I mean, if you have hundreds of devices in a building that are doing their job, are you going to go and replace them because the vendor doesn't support them anymore?
One of the things that what we do is we will sit down and look at your systems and then work through what makes economic sense. What is your risk tolerance for this? Is this system over here, there may not be any justification to bring it up to speed. You don't have to do the whole system in some cases. You got to be careful with this one, but you don't have to do the whole system. But that one brain, the application host, whatever, if you tighten it up, because a lot of times in order to get to the rest of the things, you got to go through that application server, right? So a lot of times you can do that, but I should also caution, because if you take it up too high, the devices that are out in the field may not continue to talk to it. Because if you take, for example, we run into, there was an elevator system that was running Windows NT. Well, the controllers that were throughout the building, the way the thing particularly was set up is, in order for the thing to communicate out, that version of Windows NT had to remain. Because if the devices that were out in the field would not talk to the application version that was required if you went in with, say, Windows 10. So yes, I mean there's a give and take that you have to go with. What is the mission of the building? If it's blood storage, I'm going extreme. But if it's blood storage and it has the risk of being attacked, then you might want to bite the bullet and get that one up.
You also said a little bit earlier that, ICS and building control are only cousins, not siblings. Can you talk about that? What's the difference between classic ICS and building control?
So in the building control world, there is distributed intelligence. That's one aspect of it. That's the technology aspect of it, and I'll explain that a little bit further. But I have to start off with, in the building control world, the culture is from what I understand or what I've seen, is vastly different than what ICS is. In the ICS world, if it's an oil and gas facility, the guys that are running those things are very cognizant of the fact that they are working with something dangerous, that if they don't pay attention to what's going on and they don't follow procedure, that there could be some problems that could be disastrous. In the building control space, that's not the case because of the way the culture is. So that's a big differentiator. The other thing is, from as I understand, predominantly in the ICS world, there are PLCs, and these PLCs just follow, I don't want to say they're dumb. They're not dumb, but they have a process, and that's all they do. In this world, we have supervisory controllers and field controllers that are out there in the field doing their thing and can actually work independent of that front end or application host. For example, if they lose communication to the application host, they can continue to run the things that are attached to it, like the example I used earlier, 20 whatever number of air handlers that are out there. So if it ever loses communication to the front end and somebody makes an adjustment, it will take that adjustment and pass it out to those air handlers, where controllers that don't have the quote smarts in them, they'll just run on last command. It's like, it doesn't matter what anybody does. It's just going to run until something comes and tells it to do different. So because these things have the capability to do command and control themselves, if I get to that, then that means anything attached to it, I have the ability to command and control them as well.
You've talked about preventing attack, but I remember when we were prepping for this podcast recording, you were talking as well about recovering after an attack, backups and stuff like this. Can you talk about that? What needs to be done? What do you not see enough being done of?
Comes back to culture. I may sound like a broken record, but it is what it is. 90% of the cases where we go in and do an assessment, there is no backups that are being done. Or the backups are being done, like, for example, how I told you the guy sits at the front end and looks at Gmail? Well, they're backing their systems up to the front end that they're looking at Gmail on. So when the ransomware hits, they don't have a backup. So I like to tell people that the attacks that we've seen have been 100% recoverable had they just made backups. But in our industry, that is not a priority at all. There's no process, no procedure around that. So that's why every time we see one of these, it's days, weeks for recovery, because what ends up happening is the vendor's called, hey, do you have a copy of this? And he goes, yeah, from about 2 years ago, and he puts it in and they still have to rebuild it. So that's the biggest thing in this, when you asked me earlier about what are those simple things that you could do, that's one of them. Make backups, but don't store them on the machine that you're making the backup of.
Now, CISA and the NSA, the National Security Agency in the United States, came out with an alert recently. It was a really long one. I wrote a blog post on it, but it struck me that a lot of what you're talking about, take stuff off the internet, guys, and, get some backups. A lot of this stuff was in that alert. Have you seen that alert?
I have, and I've seen your post, your blog post, by the way, which was very good. If you're not familiar with this, there's a thing that NIST, there's another entity here, another acronym or abbreviation, National Institute of Standards and Technology, the American, standards for this, is in 2019, they released IR 8228, which basically says you cannot manage OT with IT processes. And I was like, thank you, because that's what I've been saying for the past whatever length of time I've been doing this. With the NSA, it was like more affirmation of it, because they, if I remember correctly, they also reference that, or pieces of it. And the things that they're saying, I would say you could take some of those, and I would say look at your blog post too, because those would be some minimal best practices that commercial real estate groups, hospitals, whatever could do. But if I can tell you some horror stories. We've been talking about bad guy attacks, but we haven't talked about what happens when OT gets overzealous. For example, there was a hospital group with, let's just say they're across the entire United States and they have a lot of buildings. In this particular case, IT pushed out a Java update. They were like, okay, we're going to fix this problem. And so without asking anybody, they just pushed out these Java updates. The system, I won't mention the manufacturer, not because it was the manufacturer's fault, but it may identify these people. But anyway, when they pushed it out, it locked up the front ends in 50 locations. Now, that was the beginning of blocks of 50, and there was a lot more of these that would have come, but the brakes were thrown. I literally was walking in the building when this happened, and along with somebody from the organization higher up. The problem with it is how I told you the building can run itself? Well, in this particular instance, just because a building can run itself, there's operatory suites in there that are dependent on a certain airflow, pressure to keep the germs to a minimum. They had to cancel surgeries for 2 days in 50 locations. Another entity had tens of thousands of devices throughout the building, over 10,000 devices throughout the building. They ran a particular vulnerability scan against it. And what they ended up doing was they did it just like IT. Well, these devices are not robust enough to handle that. So over 60% of the devices were hard offline, meaning they had to be power recycled. So as you can imagine, it took weeks and weeks to get all of these devices back online correctly, because you don't just bring them back online. You have to verify that they are back online correctly. So, and again, I've got more IT horror stories that I tell. The point being is, I'm not picking on IT. What I'm saying is, we need to bring the two camps together so that IT understands what they can and can't do, and the OT side understands why IT is doing what they're doing. They're doing it for a reason, not just to make your life hard.
Let me jump in with a couple of things here. The NIST IR is Interagency Report 8228, is considerations for managing Internet of Things, cybersecurity, and privacy risks, if you want to look it up and read it. And yeah, it does say, in, I think, the executive summary saying, guys, if you have Internet of Things devices that are controlling the physical world, doesn't matter what part of the world they're controlling, you can't manage them as IT devices. They're a different animal. And I wanted to come back to the alert, which was, if you want to look it up, AA20-205A. NISA and CISA recommend immediate actions to reduce exposure across operational technologies and control systems. A very long name, a very long alert. My take on the alert was a lot of the advice in the alert is the same as we got on starting from zero. It was, guys, get some backups. Find your control devices that are connected to the internet and disconnect them. So, very, very basic advice from the some of the nation's highest authorities here.
Yeah, maybe I was wrong to play down this kind of security earlier. I know that doing the minimum amount possible certainly appeals to my sensibilities.
And, I agree with you to an extent, but I would change just one word. Instead of, saying do the minimum amount possible, do the minimum amount that's practical. Because some of these changes really are very simple. Get a backup, spend on your $1 billion building, spend $2,000 on another workstation and screen, so your people can go to Google and look stuff up if they need to. These are, the difference between zero and something, a little bit more reasonable are really very small. So, start with baby steps, but do start.
Is there a thought you'd like to leave with our listeners?
So first thing is, we have spent several years building this process that we have now. And I can say in all honesty, we're probably the only people at this point in time that have the skill sets in both sides of the house. And what I mean by that is we have guys who have spent years in OT, and we have guys that have spent years in IT. And we have learned to put together a program that will help people begin to bridge the gap between the two. So intelligent buildings, if you're interested in talking to us about that, we'd love to talk to you. I mean, it's a free phone call. You're more than welcome to call me or go to our website, which is intelligentbuildings.com. But something you can leave with, something you can go do, is to begin to understand and know what you don't know. And what I mean by that, I said it earlier, is are you exposed? That's something you can ask your vendor, because they would know and they would tell you, because they're the one that's probably set it up. Are you using singular accounts for multiple people? And finally, if you don't have any processes or policies in place, especially around disaster recovery, specifically around backups, if you just take care of those three things, you're miles ahead of the rest of the people out there. So, for what it's worth, again, I invite you to take a look at our website, give me a call, or email me. I'm fred.gordy@intelligentbuildings.com, or you can find me on LinkedIn pretty easy, and I'll be more than happy to talk to you.
Andrew, now that we've wound it down a bit here, it occurs to me that most of the security advice that I've drawn from this episode is rather, basic standard stuff. Make backups, don't leave devices on the internet. What constitutes advanced building automation security? What are the sort of higher level steps that those in the industry can take?
Well, to be fair to Fred here, my understanding of the industry from him and from others is that the industry really is, as a rule, at zero, and they really do desperately need the basic stuff. This is why the CISA in the Department of Homeland Security and the National Security Agency in the United States put out that alert saying, guys, please do the basics. This is where the industry is. I have limited exposure to sort of more advanced building automation. If we have guests in that regard, we should contact me and we can bring you on. But my understanding is that in certain buildings, like let's say certain government buildings or military installations, I don't know, extreme example, take the Pentagon. I'm guessing they have this stuff nailed, and they're doing much more advanced stuff. They're using best practices from industrial control systems, possibly adapted to the building automation space. But that's stuff that I hear at a distance. There are sort of shining examples out there, but they're few and far between, is the sense that I get.
Sounds like we've got our work cut out for us then. And with that, thanks to Fred Gordy for speaking with you, Andrew, and thank you, Andrew, for speaking with me.
Always a pleasure, Nate. We'll catch you next time.
This has been the Industrial Security Podcast from Waterfall. Thank you all for listening.